Today we will practice factoring algebraic expressions. So let's get started. When we factor algebraic expressions, we want to put the tiles into equal groups. So for this problem, each group will have the same number of x tiles and the same number of 1's tiles. Here, we can rearrange the tiles into 3 groups, each with 1 x tile and 2 1's tiles. And we would write this as 3, that's the number of groups we have, times the actual grouping, x plus 2. 3x plus 6 and 3 times the quantity x plus 2 are equal to each other. They are equivalent expressions. Instead of using tiles, we can also do this by finding the greatest factor common to all terms in the expression. So for the term 3x, the factors are 3 and x, 3 times x. For the term 6, well, we can factor the 6 to 2 times 3. A common factor to both terms is the factor 3. In this case, it happens to be the only factor, so therefore it is the greatest common factor. And then using the distributive property, we factor the 3 from each term, and then group what remains inside a set of parentheses. It's always a good idea to check our results, and we can check this by using the distributive property. Distributing that 3 to both terms within the grouping is going to give us 3x plus 6, which is the expression we started with. 3x plus 6 is equivalent to 3 times the quantity x plus 2. Let's look at another example. Here we have 2x minus 6. So in this case, we have 2 x tiles and 6 negative 1 tiles. We can regroup these into 2 groups, with each group having 1 x and 3 negative 1's. So we write that as 2 times the quantity x minus 3. This is the same as 2 times the quantity x plus negative 3. Therefore, 2x minus 6 is equal to 2 times the quantity x minus 3. These are equivalent expressions. Another way to factor instead of tiles is using the greatest common factor. The first thing I will do is turn subtraction into addition. So instead of having 2x minus 6, we rewrite this as 2x plus a negative 6. We can then factor each term. 2x is 2 times x, and then negative 6 is 2 times negative 3. I intentionally wrote this as 2 times negative 3. It can also be written as 3 times negative 2. But because I already had that factor 2, I knew that that was going to be a common factor. So 2 is a common factor. It's the only factor in this case, so it is our greatest common factor. So we use the distributive property to factor out the 2. That leaves us with x plus negative 3. We then convert this to subtraction, and we have 2 times the quantity x minus 3. So let's look again at the distributive property. For all real numbers a, b, and c, a times the quantity b plus c is equal to a times b plus a times c. We are distributing this a to each term within the parentheses. And when we do this, we are expanding using the distributive property. So in this case, we have 4 groups, and each group is 5x plus 3. We distribute the 4 to each term, and we end up with 20x plus 12. Now if we start with 20x plus 12, we can factor out, or factor the 4 out of the expression, leaving us again with 4 times 5x plus 3. The expressions are equivalent, they just look different. Now using tiles can be nice sometimes, but it's not very practical. So let's practice factoring these by finding the greatest common factor. So to factor 6x, we have 6 times x plus, and then factoring 18, we can factor that as 3 times 6. There are other ways of factoring 18, but since I saw that I had a 6 here, and knowing that 6 is also a factor of 18, I chose to factor 18 with 3 times 6. Again, 6 is a common factor. It's the only factor in this case that's common. So we'll factor out the 6, leaving us with x plus 3. When I factor algebraic expressions, I always check my answer using the distributive property. So I distribute that 6 to both terms within the parentheses. That's going to leave us with 6x plus 18, which is what we started with. In the second problem, we do have subtraction, so I'm going to convert this to addition first. So 20y plus a negative 5. So for 20y, we have 4 times 5 times y plus, and then for negative 5, I'm going to factor this as negative 1 times 5. That way we have the 5 and the negative 1 as factors. So a common factor between both is 5. It's the only factor. So we can factor out the 5. And that leaves us with 4y plus a negative 1. And then we will change this to subtraction. So 4y minus 1. Again, checking our answer using the distributive property. We're going to go 5 times 4y. Well, that's 20y. And then 5 times the negative 1 is minus 5. 20y minus 5 is what we started with. For this third problem, we have negative 2x minus 8. So again, I will start with converting subtraction to addition. So we have plus a negative 8. We can factor this in a couple different ways. I'll go ahead and factor this as negative 2 times x plus negative 2 times 4. Both have negative 2 in common, so we factor out the negative 2. That leaves us with x plus 4. Now another way of factoring this is we can factor out the negative 1 times 2 times x plus negative 1 times 2 times 4. And this time, both terms have a negative 1 and a 2 in common. So we factor out the negative 1 and 2. That leaves us with x plus 4. And then we multiply 2 times negative 1. That's negative 2 times x plus 4. In both cases, when we check our answer, negative 2 times x is negative 2x, and negative 2 times 4 is negative 8, leaving us with negative 2x minus 8, which is what we started with. For the final problem, we have negative 3y minus 7. First step will be converting subtraction to addition. So negative 3y plus a negative 7. Now we're going to factor these. So instead of negative 3, we can rewrite this as negative 1 times 3 times y plus, and then instead of negative 7, we can have negative 1 times 7. They have negative 1 in common, so we factor out the negative 1, leaving us with 3y plus 7 within the parentheses. So we can write it as negative 3y plus 7. And then checking our answer. Again, this is negative 1 times 3y, so that's negative 3y. And then negative 1 times 7 is negative 7. Back to where we began. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. For this first problem, we have 3x plus 3. And for the first term, we factor it as 3 times x. For the second term, which is the number 3, I factored it as 3 times 1. Now, although I didn't show it in the other problems we worked on today, 1 is always a factor. Because when we multiply a number by 1, we just get that number in return. 1 is a factor for any number. Now, I did it in this case because the greatest common factor here is 3. And when we factor out that 3, that's going to leave us with x for the first term and 1 for the second term. So we end up with 3 times the quantity, x plus 1. For the second problem, we have negative 7y minus 35. Again, I converted that subtraction to addition first. So we end up with plus a negative 35. Then I factored negative 7 as negative 1 times 7 times the y. And negative 35, I did go ahead and factor it as negative 1 times 5 times 7. These two terms have both negative 1 and 7 as common factors. So we factor out the negative 1 and 7, leaving us with y plus 5 within the parentheses. And then negative 1 times 7 is negative 7. Now we could also have factored this as negative 7 times y plus negative 7 times 5. And then we factor out the negative 7, leaving y plus 5 within the parentheses, which is the same answer we got here. Again, we'll convert subtraction to addition first. So in this case, when I factored the negative 2, I factored it as negative 1 times 2 times 1. I included the 1 as a factor in this case because the greatest common factor in this expression is negative 2, which is also the first term. So what remains is 1. Negative 2 times 1 is negative 2. Finally, we have 5b minus 55. Once again, converting subtraction to addition first. The greatest common factor is 5, and we're left with 5 times the quantity, b minus 11. Continue practicing factoring algebraic expressions, and I'll see you in the next video.